Right, we can turn to the original fault now. Ignore this sort of dark bar across the middle. That's not there, it's just this camera. It's alright, this camera, but it's not very good for recording CRTs. That VHS CCD one's better. It's 50Hz. But anyway, it'll do. You can still see fault. So you see all these black dashes on everything. Wherever there's like any sort of black to white transition, or like these highlights here, you've got all this like inversion. You can see it down here. Well, maybe can't on that, but you can certainly see it around here. Also, it's in black and white. There's no colour. So this is when you get this sort of fault, it's usually it's usually in the FM. Well, it's in the FM section. So it could be heads, I suppose, but I think it's probably like something in circuitry. I don't know if the lack of colour is part of the same fault. I suppose it could be heads. No one way to find out anyway. I'll just get the circuit and trace it through, follow it from heads and follow it through luminance FM signal path, and see if I can see what's going wrong. These are the inputs. These come from the heads. That's the output to the head. And these three transistors there, the record and playback, the switch between record and playback. So when it's in playback, that one's on, so it sort of earths this end at head, and then when it's in record, these ones are on, so it earths that end, that one's off, it allows that through. So then the signals from heads come down here. There's these peaking circuits. These sort of set the resonance and what have you. At heads, there's a filter amplifier, head switch impulse comes in here, and this is where the switching takes place. So then you've got the switched output here, and that's taken off to colour circuit there. Comes in here into this amplifier. That might be where colour signals removed. Then it comes into this this chip here, this FM. That's got demodulator. It's got a few things in it. Comes in here and it feeds this dropout detector, and that switches this gate, which it's got two inputs, so it switches between two inputs depending on output of this dropout detector. One input is the original input, and another one is the line that's just been put out, that's been circulated back round through this delay line, so it's the previous line. If there's a dropout, it'll replay line before. Comes out here, we've got a test point here, and then it goes into this. These are limiters. Uses like a double limiter. VHS, you've got like the high frequencies get limited, and then gets added with low frequencies and it gets limited again. You just come in here into this another limiter, an FM demodulator. So what you'll have here will be, yeah, that's a demodulated, FM demodulated signal that'll be all full of carrier, which then gets filtered out by this filter here. So we've got a couple of test points to go at where we know what we should be seeing. There's these from Eds. I think next one's this one over here, but I'll follow it through on scope. Right, okay. So I want to have a look at the FM signal. I don't think I'll be able to pick much up here where it's just coming straight off at Ed, so I'll start down here at this transistor. As after this initial amplifier Ed switching thing, follow it through, and because I'm interested in these what's happening with these limiters, because if they're faulty or misadjusted, that'd cause that problem. But it could be Ed's, because what happens comes in here like I explained, and this is a well, it's an amplifier, and it includes a high pass filter to pass only the high frequencies, and they're limited first, comes back in here and is combined with the unlimited, the main signal that's not been limited, comes out of here, and then the whole thing gets limited. So if that's not working, what you get is you lose high frequencies, which equates to white in picture, and obviously when you get that, you get it just drops out and you get black. Press play on tape, and this is the input to that. This is that Q10. That's Q11, sorry. It's the second transistor of that amplifier, and see, we've got a signal there. That gap that you can see, that's just not there. It's just from camera. So it goes to there, and then it goes in to IC 3004, sorry, at pin 7. 1, 2, 3, 4, 5, 6, 7. So it's there, and then it comes out at pin 10. You can see that. It's looking alright so far. Goes into IC 3008 at pin 11. That's pin 1. That's it there. After being high pass filtered and amplified, it comes out at pin 2. And that goes into pin 14 with this first limiter. The output of that is at pin 8. It's that. That looks alright. Synchronise this to a switching thing. That's better. I'd say better if I turn that up. So it goes into pin 13 of the of that IC3008 chip, where it's recombined with the original signal and emerges at pin 14. That's there. And it comes through this capacitor, and then it goes to it's got two paths, one straight to pin 14 connected directly, and another one through the limiter balance controlled pin 13 at IC3004 or pin 14. Pin 13. What's that limiter balance? I think we might have found the problem, because that should be directly connected to that. You can see it's just dropped away, there's note there. So it's disappearing somewhere, goes through that capacitor, and then it's disappearing somewhere between there and here. Well, here. I'll have a look at the board. So on the board, that's pin 14. This is that capacitor. Goes down there, and then it goes on to the other side of the board. It comes out of this capacitor here, and it comes down to here on the other side of the board, and then it comes up here, and then it disappears off somewhere under this delay line, and then comes back out here, because this delay line's like raised up, and then there's components soldered underneath it. So to see what's going on, I have to remove this delay line, which I might do that actually, because if that trace is damaged, then there must be something that's caused it. There's probably like a capacitor leaked or something under there. So I think that'll be my next step, is to remove this delay line and see what's underneath it. These test points and numbers of some of these ICs and that, they're a bit different on here from what they are on board. So I don't know if this is for a different version or an earlier version. Everything seems to be the same as far as I can tell, but it just seems to be numbered differently. But I'm best checking in case there is something else going on. So this is the trace here, and you can see it's quite corroded. So I don't know if it's this capacitor that's leaked. Could be, it probably is, or if it's, I don't know if it's just sort of damp that's got to it, but you can see that that's like, it scrapes off, it's just all gone green. There's probably breaks in it. That's going to there. So what I'll do, I'll replace this capacitor, and then I'll just solder a wire to connect them up. I'll do that on top of the board, well, on the other side of the board. I'll get a little bit of a clean with some alcohol to get rid of that green stuff. Yeah, you can see it's well, I don't know if you can see, but there's no left at trace there. Legs of that capacitor look a bit ropey as well, so I'll replace that. I'll do. The more you look at this board, the more you can see places where capacitors have leaked and traces have gone green. Like there's a bit here, one there. I don't know where that's going. It's hard to Let's go up there. There's one a bit up here. There's that one that I've already seen. Sure there's another one somewhere. It's these like little black Panasonic capacitors, whenever you see them in stuff from, there's another one up here. Whenever you see them in stuff from early 80s, it's just like, they always leak. And the way that this is, with it being double sided, there's all these traces on here that it's leaked onto. If it were single sided, it, you know, it wouldn't have had you know, as much of an effect. I mean, capacitor would be knackered, but like it wouldn't have eaten traces. It's like, how far do you go with it though? I'll replace this capacitor and see what happens anyway. Right, give that a try now, see how that's done for it. Plain. That's a lot better. If you can see that or not. Let's get rid of them let's get rid of them black streaks. Right, they were around here and oh yeah. Still in black and white, but getting there.